Hello and welcome back to NTMAU. This problem is found on page 196 and it is problems number 4 and 5. With this one we begin same as we did the last problem, and that is finding angle A. Angle A is determined by knowing that you start with line or point C and you end with point D. So let me sketch that up. And to determine the angle you begin with the first point C, and you sketch it down to the second point, which is A, and then you sketch it over to the third point, which is D, and then back up. Here is our 90 degrees inside here. Okay? They want to know what the included angle is as well. So the first thing we have to do is solve for this angle here, and we know that it's this angle because it asks for A. Begins with C, ends in D. The one in the middle is the one that it's actually the one that they're determining. Okay? So the first thing that you see here is it says the surface AB is 750 inches. So we find AB, that's the distance from here to here. That's 750. And the next one is, let me fix this just a little bit. The next one is surface AD. That's the distance from here to here, and they say that's 6 inches. Okay, so we have 6 inches here. All right, now I'm going to clean this up some, and then I'll be right back on this thing. Okay, so take a look at the problem as it's set up. We know that we have surface AB, that's from here to here. They're telling us that it's 750,000, so I've taken the 750 and I've put it here. The next one is surface AD. What you want to do is go for all the information that you know and format your problem with all that information. And especially as we get into some more of the complex trig problems, you want to go for what you know and put that down. Write it down, because if you don't write it down, you're going to be looking at a blank page, 5 minutes from now, 10 minutes from now, or whatever else. Write everything you know down on the paper. Write it in pencil, preferably, because then that way you can erase it if you see that you've made an error. But the bottom line is, write it down. Sketch everything out. Sketch your angles out, the whole 9 yards. And you'll see that as we go through the trigs and some of the more advanced trig, it'll work out a whole lot better for you. So the next one we have is distance AD. So here's distance A to distance D. That's 6 inches. And then the last piece of information that we have is surface CF. So we go from the letter C down to the letter F. We know that that distance is 1.5. So how are we going to figure this out? Well, we know that we've already got the adjacent side here. This is the angle that they're looking for. They told us that in surfaces CAD, CAD. So this is the angle that we're looking for. Since that's the angle we're looking for, this becomes the adjacent side, right? We know that the adjacent side is 6 inches. And what we want to solve for is what is this angle per se. So in order to solve for this angle, we've got to have two functions. We've got to have two things. So I need to know what the distance is from surface CD, from here to here. That would give us the opposite side. So the opposite side and the adjacent side would equal the tangent, right? So write all of this stuff down. And then I'm going to bring up the formula sheet that shows you how to solve for an angle when you have an opposite and you have an adjacent. Now, in order to solve for this, what we need to do first is come up with what this adjacent side or this opposite side is, this distance from here to here. So we do that by taking 1.5 minus 750 thousandths. We know that we got a distance from here all the way down to here of 1.5 inches. We know that this whole distance here is 750 thousandths, right? So if we take 1.5 from 750, that's going to give us 750 thousandths total, the distance from here to here and the distance from here to here. We don't need the total from here to here and here to here. We only need half of that, so you take 750 minus 2, or divided by 2. And that's going to give us a distance from here to here, of 375. Now I wish this number wasn't exactly half of this, because then it would be easier to understand this, I believe. But again, let me show this to you, or let me explain this to you. We know we have a distance from this point to this point of 1.5 thousandths. We know that this surface here is filled with 750 thousandths total. So if we take the 1.5 and subtract 750, because we know what this distance is here, that leaves us with a total distance of 750 thousandths from here to here and from here to here total. So in other words, if we took this out, completely move this up, the distance from this point to this point would be 750. I hope that explains that a little bit better. I'd like to just take this, fold it up, and then you would have the angle where it would be an inclusive angle, and it would come down something like this, okay, replicating what we've got here. All right. So basically all I'm going to do is take this and move it up to here, right? And we would have something that looks like that. All right, there's our angle inside there. So we've got 375 here, and we've got 375 here. We don't need this one, we only need this one. This is going to be the opposite side, so it'll be 375, because 375 and 375 is 750. And again, all I'm doing is taking this angle right here, and I'm moving it straight up so that it touches this. By moving it straight up, I know that I've got a distance then from this point to this point, which is now the distance from this point to this point at this angle, on this angle here. All right, so 375 and 375 equals the 750 difference. We got the 750 difference by taking 1.5 minus 750 divided by 2. All right. That's going to give us our inclusive angle. That's going to give us the distance from here to here when we solve for this. Let me make this angle a little different color. Alright, I hope this makes this a little bit more clear. Bottom line is I'm taking this line here and I'm moving it up to here. This angle right here is this angle right here. This side right here is this side right here. We know then that this would become our inclusive angle. That inclusive again means both angles included. So basically we solved for a distance or an unknown of 750 thousandths with a total between this angle and this angle. And when we take this angle and this angle, divided by 2 from that 750 thousandths, we get 375 here and 375 here. I know I'm going over this a lot of times. I just don't know whether or not everybody understands this and if it's clear. So I hope it's clear. And let's move on with the problem. So this establishes our opposite side. So this is the opposite side. We know that we've got 6 inches here of the adjacent side. All right, I'm going to bring up that sheet that I was telling you about, and all of this is going to go away. So if you need to make sketches, please do so. Pause the video, and then we'll come back and work with this with the calculator. Okay, so now I've got the problem set up. It's going in the opposite direction. This surface here is actually this surface here. This surface here still remains this surface here, but A is A. I've got these switched around too, so don't pay attention to that. This is just taken from another one of this, but this is a formula that you would use, and it is on the cheat sheet that's on your math help list, so in the Blackboard system. So check that out. There's a whole list of different solutions, formulas, and so on that you can get on that math cheat sheet. It's called the True Cheat Sheet. So we know that this distance from here to here is 375 thousandths, and this is 6 inches. So this is the opposite side. This is the adjacent side. So the opposite side goes on the top, opposite side. The adjacent side, the 6 inches, goes on the bottom. Now you take 0.375 thousandths and you divide it by 6, because that's what that says to do. You're going to come up with 0.0625, or 62.5 thousandths. Now what you need to do is find the angle whose tangent is 62.5 thousandths. So to do this, use your scientific calculator, or use this calculator here, and what we're going to do is plug in 0.0625, okay? And then if you move down on this thing, it'll tell you the next thing to do. We've got to come up with the tangent 1 key, the tangent minus 1 key. And you can get that on this calculator by hitting the invert key. So take a look at your calculator, bring your calculator up, Hit the invert key. That's going to take this tangent and give you the tangent minus 1, or to the first power. So hit invert, and here you can see now that the tangent is tangent minus 1, tangent. And we come up with 3.5763. That's this angle right here in degrees, decimal degrees, okay? That is this angle here. Now, the trick on this thing, though, is that they're saying, what's the included angle? They want to know what the distance is from here to here and from here to here combined. So that would be this angle here. It doesn't matter that you've got this space in between here. Just, again, move this up to here, and it's an inclusive angle. Or if you just draw the line from this point all the way to this point, it's an inclusive angle. Doesn't matter. You can multiply it times 2, but and you can go ahead and do that, and it'll come up with your degrees, decimal degrees for both of these angles. But it also asks for what is this angle in degrees, decimal degrees. So what I'm going to do is I'm going to hit the memory store key. This will then tell me, or at least keep this in storage. This is the degrees, decimal degrees in storage. Okay, so it's stored, and I'll show you how to bring that up later. So memory store, and then what we're going to do is hit the DMS key. That will tell us that we have 3 degrees, 34 minutes, and 34 seconds. If you want to round it up because you've got another 8 over here, that would make it 35. So you got 3 degrees, 34 minutes, and 35 seconds from here to here. Okay? That's from there to there. So you've just now solved for your first angle. Now, let's go back to this. Let's clear this out. And let's go to memory restore. That brings back up what we had saved in the memory. That'll stay there until you delete this calculator off here. So that's the same number you had before. It's just in storage. And what we're going to do now is multiply it times 2 because we want to get this inclusive angle. So we have to work in degrees, decimal degrees, times 2. Okay, so we're going to hit times 2 equals 7.1526. 7.152 and 6/10. Now this is degrees, decimal degrees. Everything we do is in degrees, decimal degrees. We want to convert it to degrees, minutes, and seconds. So we're going to hit the DMS key. And our answer is 7 degrees, 9 minutes, and 9 seconds. And if you want to round it up because you've got a 6 at the very end, you could make it 7 degrees, 9 minutes, and 10 seconds. And that's it. That's how you solve for an angle. You can save this and also reference this on your cheat sheet. These numbers are not there. Other numbers are there, but at least you can replace the numbers for when you need them, for whatever numbers would fit. So again, all you got to do is check out your cheat sheet, and this is going to be in a right angle triangle, ABC. It gives you these legs and everything else, and this is to solve for an angle. All right, and it will say that to solve for an angle will appear at the very top. I'm going to put that in there for you. All right, that about does it with this this video, and we'll move on to the next one.